So we are looking at what we are calling as being the electromagnetic spectrum. So in the electromagnetic spectrum, all the waves that are found in the electromagnetic spectrum are all transverse waves, meaning that if this is a particle in a transverse wave and that is representing the motion in which the wave is traveling, the particle is going to be moving perpendicular to the direction of travel of the wave. So that is what we mean in this case. So in the exam, sometimes they can tell you to illustrate how the particles in a transverse wave are moving. So they move perpendicular, and that's the word that you need to remember. So perpendicular. So they move perpendicular to the motion or the direction of travel of the wave. So that is what you need to remember. Of course, you can say at right angle to the motion, or the direction of the wave. So what are these waves that are found in the electromagnetic spectrum? Or the waves that are found in the electromagnetic spectrum in the order, you can remember the memory aid: run, mouse, in, very, unpleasant, extreme games. So this is what you need to remember. So once you remember this memory aid, then you know the order in which the waves in the electromagnetic spectrum are going to be. For example, the arrow there is representing what we call as being radio waves. So radio waves. The M there is representing microwaves, and the I there is representing infrared waves. The V there is representing visible light, and the U there is representing ultraviolet. And you can see in the word extreme, the X has become extreme, so that is representing the X-ray. Then the G there is representing the gamma rays. So you can see that run, mouse, in, very, unpleasant, extreme games. So those are actually representing the waves that are found in the electromagnetic spectrum. So they are going to be telling you to actually, they are going to eliminate some of them, and they'll tell you to identify which waves are there. So they are going to be existing in that. Now you need to remember that as you move from gamma rays going to radio wave, as you move in that direction, one thing that is notable is that the wavelength lambda there, so the wavelength increases. So if I ask you which one has the largest or the longest wavelength between gamma rays and radio waves, obviously radio waves are going to have a longer wavelength, because as you go in that direction, you're going to find that the wavelength actually increases. Now as the wavelength increases, you are going to find that as you move in that direction again, so as you go in that direction, you are going to find that the frequency decreases. Yeah, so if you are moving in that direction from gamma rays to radio waves, you are going to find that the wavelength is actually going to decrease. Or we can say, going in that direction, the frequency actually increases. It actually increases from radio waves to gamma rays. So if I told you between microwave and ultraviolet, which one has actually the highest frequency, then ultraviolet would have the highest frequency. So that is what you need to remember. Now I want to talk about something that is actually important in this electromagnetic spectrum that we have. Remember, this is representing visible light. So if you were to split visible light, you are to pass it through a prism, you are going to find that it is going to be split up into a band of colors that we call a spectrum. So you find under visible light, you create what we call Roy G. You are going to create what we call Roy G bead. So this is going to be created. So that's a red, orange, yellow, green, blue, indigo, and violet. So again, if I was to ask you, going in that direction, which one has in this case the highest wavelength between blue and orange? Of course, orange will have the greatest wavelength in this case, because as you move in that direction, you are going to find that the wavelength increases. So sometimes what they can do, instead of starting with radio waves going all the way to gamma rays, they can actually flip it up, meaning that we can have run mouse in very unpleasant extreme games. So you can also have the electromagnetic spectrum in this manner that you are going to have. So starting radio waves, microwave, infrared, visible light, ultraviolet, x-rays, and gamma rays. Again, when it is flipped going in that direction, it simply means that even your raw GB will be split. So your R, your O, your Y, your G, your B, your I, and your V. So these are going to represent this band of colors that is found in visible light, again, when you actually split it up. So now the question is, how do these waves in the electromagnetic spectrum, how do they differ? Because in the exam, they are going to ask you how they differ. What's the difference? Well, mainly, they actually differ in terms of what we call as being the wavelength. So the waves that are found in the electromagnetic spectrum have got different wavelengths. Then two, they differ in terms of what we call as being the frequency. So you are going to find that the waves in the electromagnetic spectrum have different frequencies, So that is what you are going to see. That is going to be the difference that is going to be existing. So now I want to actually show you a bit of some similarities. Sorry for the noise happening in the background. So we are going to look at now what are some of the similarities of these waves in the electromagnetic spectrum. So what are the similarities? So in terms of the similarities that you are going to have, number one, we can say that they all obey, the wave equation. So they all obey the wave equation. That wave equation, the speed is equal to frequency multiplied by wavelength. Then we can say they are all transverse. They are all transverse waves. Then three, we can say that they all travel at a speed. So they all travel at a speed of 3 × 10⁻⁸ meters per second. Then we can also say that they can be reflected. So they can actually be reflected, they can actually be refracted, they can also be diffracted in this case. Then they carry energy from the point. So they actually carry energy from the point of disturbance. So that is what you are going to find. So these are some of the similarities that are going to exist between all the waves that are found in the electromagnetic spectrum. So just watch out for a question that I'm going to look at, so that you can see how you can apply this concept in answering some examination questions. Thank you so much for watching.